Bismillahirrahmanirrahim. This is February March 2023, paper 4, theory extended version. Question number 1. This question is a vector related question. In this question, examiner says a boat crosses a river. The boat points at right angle to the river bank and its travel at the speed of 3.5 meters per second relative to the water. River current at right angle to the direction of the boat, and the river current has a speed 2.5 meters per second. By drawing a scale diagram or by calculation method, determine the speed and direction of the boat relative to the river bank. We are given both methods. We are given two methods, one scale and calculation. So this is your choice, which one you choose. So I will solve this question with both methods. Because there is no any particular direction given by the examiner, river as well as boat. So we can imagine, let's say this is the direction of river current, that is 2.5 meters per second, and boat is going in this direction with the speed 3.5 meters per second. I will use a scale diagram. For the scale diagram, I need a scale. So these numbers are very small numbers. So I will choose a small scale to make a reasonable size diagram. So for this diagram, let's say 1 centimeter will be equal to 0.5 meters per second. So according to this scale, if I find the length of if I convert 3.5 meters per second into centimeters, then it must be 7 centimeter, and 2.5 meters per second must be equal to 5 centimeter. Okay. As it is given, like both are 90 angles with each other, both are right angle to each other. I will draw by scale. As you can see, like this scale, this scale, there is no any numbers are given. So I will choose this distance as 1 centimeter, right? I will consider this distance as 1 centimeter. So I have to draw 5 centimeter. I have to draw a 5 centimeter. That is actually speed of the boat. I will represent it into vector form. So from here, it's 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, and 5 centimeter. This is 5 centimeter. And then at 90 angle, I will draw a 7 centimeter. Okay, this is 90. So 1 centimeter, 2 centimeter, 3, 4, 5, 6, and 7. Unfortunately, I choose actually the position of this diagram. I can little bit change. Uh, okay, now it's fine. Okay, so let me mark the no, let me mark the direction. This is the river direction, and this is the boat direction. According to head to tail rule, I add both vectors because velocity is a vector, and I convert these. I add them by scale because I'm using a scale diagram. So I will add them by head to tail rule. And when I will add them head to tail rule, then this will be the resultant of addition of these two vectors. As you can see, this is 2.5 meters per second representation. That is actually river. And this is 3.5 centimeter that representing, sorry, 3.5 meters per second that representing the boat. Okay, so this is my scale diagram. Now I need the resultant value. So for the resultant, I will use my same scale and I will measure the length of this resultant. According to this measurement, I will use the same method once again. This is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5, 6, 7, 8. and 8.1, 8.2, 8.3, 8.4, 8.5, and it is approximately 8.6 centimeter length. Mean this resultant gives me the length. This resultant gives me this resultant is equal to 8.6 centimeter. And I already have used this scale, and according to this scale, this 2.5 centimeter representing 5 centimeter, and this 3.5 meters per second representing 7 centimeter. So when I add 5 centimeter and 7 centimeter by head to tail rule, then I get this resultant, and this resultant is equal to 8.6 centimeter. Because I want to write the answer in meters per second, so I will convert this number back to the scale that I used in the beginning. So this 8.6 centimeter will be equal to 4.3 meters per second, right? Because I multiplied this length with the given scale, with the used scale, 8.5 multiplied by 0.5. So I got the speed 4.3 meters per second. So here I have answer 4.3 meters per second. Now I want to find out the direction. So for the direction, I will use this. This is not a protector actually, but this scale is actually working as a protector. So you can see, because when I place this scale on this given diagram, so this resultant and relative to the river bank angle is 55. So I will write here angle 55 because I need to calculate this angle that is relative to the river velocity, that is relative to the river. So this direction relative to the river is equal to 55 degree. This is one way to tackle this question by scale diagram. If you want to solve this question by calculation method, then you can use Pythagoras theorem. And for this purpose, again, uh, okay, because this is space, less space is there, so I will solve the question with calculation method here on this space by calculation method. So by calculation, again, let's say this is the speed of the river, okay, 2.5 centimeter. Uh, this is 3.5 centimeter, that is the boat speed, and here will be my resultant. Because this time I didn't draw the diagram with scale. This is just idea of the question. So we need this angle also because river speed is this, right? So by Pythagoras theorem, I need this resultant. So resultant will be equal to 3.5 square plus 2.5 square. If you will add them by taking square as well as taking under root, you will get the answer. And that answer will be equal to 4.3 meters per second, right? We need the angle relative to the river, right? So according to this theta, this will be your perpendicular, this will be your adjacent or base. So I will use the tangent theta. So tangent theta will be equal to perpendicular over base. I need the value of theta. So theta will be equal to tangent inverse. Perpendicular is 3.5, base is 2.5. If you will use the calculator, you will get the answer 55 degrees. 55 degrees. So this you can see by using calculation method as well as by using scale method, we are getting the same answer. So part number 1A is over. Now part number B. In part number B, examiner gave some idea about the scalar. Speed is a scalar and velocity is a vector. So state names of one other scalar quantity and one other vector quantity. So we have multiple options, many options you can write, many name you can write. I can write for the scalar, I can use mass is a scalar, density is a scalar, volume is scalar, energy is scalar, power is scalar. So many options you can use. In for the vector, you can write displacement. Displacement is a vector that distance between 2 points in particular direction, shortest distance. You can write velocity, you can write momentum, and so on. So these are more than enough. So this is a question number 1. Question number 2, in this question number 2, figure 2.1 shows the ship loaded with a container. The ship is made up of steel and the density of the steel is 7800 kilogram per meter cube and density of water is 1000 kilogram per meter cube. Explain why the ship floats in the river. Okay. By rule, all those things will be sink into the water that have a density more than water. And all those things will float on the surface of the water whose density is less than water. But here you can see here the density of the steel is 7800 and density of water is 1000. It means density of steel is much greater than water, but still this steel boat is floating on the water. So what is the reason? The reason is that definitely, this ship contains some luggage and containers and different contents. So, if we talk about the overall density, then overall density definitely less than density of the water. So, you can write that overall density of the ship, the overall density of ship and its contents less than density of water. Okay, question number 2. The containers with the greatest mass are loaded near the bottom of the ship. State and explain the effect of the stability of the ship of loading the containers in this way. Okay. You know, when we talk about a stability, then stability depending upon the center of gravity. So when center of gravity is very close to the surface, if an object have a center of gravity very close to the surface, then that object must be more stable. For example, if imagine like I have this surface and on this surface I place this block. Imagine this block is, imagine you can say it's a kind of, it's a book. I place this book on this table, so its center of gravity is very close to the surface of the table. But on the other hand, if I have a pencil or pen in my hand or any long object like a stick, so for this case, the center of gravity definitely at the center that is away from the surface. So if I apply a small force, then this will be unstable and this body will not be back to its original position. But if I disturb this, if I lift this book up and drop it, it will be back because of its gravity point, its center of gravity close to the surface. So you can use this concept here. You can write the center of gravity of the ship, the CG, center of gravity, of the ship will be low that increase its stability. That increase its stability. Okay. The last part, a crane lift a container 48-meter vertically upward. The mass of the container is 30,000 kg. Calculate the energy transferred to the gravitational potential energy stored in the container. We have to find out the gravitational potential energy. So for the gravitational potential energy, we have only one formula, and examiner says that find out the gravitational potential energy transfer. So change in potential energy will be equal to mgh. So mass is given to you 30,000, gravity value you will use 9.8 for the surface of Earth, and mass is given to you 48 meters. 48 meters. If you multiplied all these numbers, according to my calculator, I'm getting the answer 14112000, and this is energy, so unit must be joule. I will write this number in scientific notation, so point must be here, so I can write 1.4 into raised to power 1, 2, 3, 4, 5, 6, 7, 7 joule. Question number 3, state the principle of conservation of energy. So this is very easy question. According to this principle of conservation of energy, energy can neither be created and nor can be destroyed, but it can be converted from one form to another form of energy. For example, if you drop an object from height, then at a particular height, the energy is mgh, that is potential energy. As you drop this object down, then what will happen? As body is coming down, its speed will increase, speed increase, and height decrease. So near the surface, all the potential energy converted into kinetic energy. When this body will hit the ground, so maybe you hear the sound. So one form of energy can be converted into different form of energy. Part number B of the question, part number B. Examiner says that a wind turbine has a maximum output power 1.8 megawatt and turbine operate a maximum power for 4 hours. Define the unit kilowatt hour. I hope you remember you have studied the energy formula of energy, like energy is equal to power times T. Energy is equal to powers times T. So you can see that kilowatt, this is the unit of powers, time is the unit of time. So you can see like a kilowatt hour is the unit of energy. Okay. So I can write the answer. Actually, kilowatt hour, it is the unit of energy. It is a unit of energy that can be calculated. This energy can be calculated if you will take the power in kilowatt, multiply the time must be in hours. Okay, and I hope so you know well that kilo will be equal to 1000. So energy will be equal to in kilowatt hour. Question number 3, part B. Calculate the energy produced by the wind turbine operating the maximum power for 4 hours. Give your answer in kilowatt. We will use the data in B part, and you need to calculate energy in kilowatt. Okay, so I can write the formula. Energy will be equal to power times T. So power is given to us 1.8 megawatt. So 1.8 mega, you know well that mega will be equal to 10 raised to power 6. So 1.8 into 10 raised to power 6 multiply by the time, that must be in hours, and that already given in hours, so it will be 4. time will be 4. When you will multiply, then you will get the answer. If you will multiply, then you will get the answer 7200000. This an answer is in joule, but uh, this answer is in watt hour, right? Because power is given into watt and time is given in hour. So if you convert the watt into kilowatt, then you have to divide with 1000. So when you will divide with 1000, then your answer will be 7200, and it must be in kilowatt. Because you know well, when energy is given, when prefixes are used, for example, if energy is given 5000 joule and you want to convert it into kilojoule, then you have to divide. When you will go from smaller unit to bigger unit, then you have to divide. So you will divide with 1000 and then you will get the answer in kilo. That's like kilojoule. This must be in kilojoule, right? So that's the reason I did, because watt is a smaller unit. So I want to write the bigger unit. So I divide with 1000 and my answer is in now kilowatt. The last part of this question, examiner says that um, radiation from the sun is the main source of energy for most of our energy resources. State two energy resources that are not due to the radiation of the sun. So not due to radiation of sun, right? So one source of energy may be a geothermal. And second one, you can write the nuclear energy. These are the two resources of energy in which sun radiations are not directly involved. Even not involved. State two energy sources that are not due to radiation from the sun. So yes, geothermal and nuclear energy. These are the two energy sources that are not due to the radiation from the sun.